In this video, we'll learn about velocity versus time graphs. We'll start by adding labels to our x and y axis. The x-axis is time. In this case, the units are seconds. The y-axis is velocity. In this case, the units are meters per second. Now that our graph is labeled, we need to add some points. I will start by drawing a number line. This number line represents the object's velocity. So the first point would be 0 meters per second. Then the velocity increases to 1 meter per second, 2 meters per second, 3 meters per second, 4, 5, 6 meters per second. Now imagine we had some car, and this car is stopped, so its velocity is 0 meters per second. But we know the car will turn on its engine and start speeding up, and it will accelerate at a rate of 2 meters per second squared. So what happens to the car's velocity? Well, after 1 second, the car will be moving with a velocity of 2 meters per second. If you are confused where that number came from, look at this. We have 2 meters per second squared. That's our acceleration. And we move for 1 second. When we multiply those numbers, look at how our units cancel out so that we're left with 2 meters per second. If the car drove for 2 seconds, then it would be at a velocity of 4 meters per second. All we have to do is 2 meters per second squared, our acceleration, times 2 seconds, and we get 4 meters per second. Now what if the car drove for 3 seconds? Well, then it would be at a velocity of 6 meters per second, because 2 meters per second squared times 3 seconds is 6 meters per second. Now that we understand how the car's velocity changes over time, let's plot this on our velocity versus time graph. Initially, we're right here at 0 meters per second, and no time has passed, so our first point will be right here at 0, 0. And then in 1 second, the car speeds up to 2 meters per second, so we mark that here. The car then speeds up to 4 meters per second after 2 seconds, so we mark that here. And finally, the car reaches 6 meters per second after 3 seconds. Once our points have been plotted, we can draw a line through all the points, and now we have a velocity versus time graph. Now let's go over the most important points you need to know about velocity versus time graphs. The first point is that when an object moves with a constant acceleration, the velocity versus time graph will be linear. So our car was moving with a constant acceleration of 2 meters per second squared, and our velocity versus time graph is linear. The second point is that the slope of a velocity versus time graph is the object's acceleration. What that means is we can use our m is equal to y2 minus y1 over x2 minus x1 slope equation to solve for the slope of this graph, and we would know the acceleration. And let's confirm that here. We know our x1 was 0 seconds, our y1 was 0 meters per second, our x2 was 3 seconds, and our y2 was 6 meters per second. When we plug those numbers into our equation and do the math, the slope of this line is 2 meters per second squared, which was the acceleration of our object. The final point is that the area under the curve is equal to the object's displacement. And remember, displacement is just the object's change in position. But what does area under the curve mean? Well, if we draw a line from our final point here all the way down to our x-axis, what we see is that we form a triangle. And what we need to do is find the area of this triangle, and that is equal to the object's displacement. So let's do that now. We know that the area of a triangle is base times height divided by 2. Our base is 3 seconds, and our height is 6 meters per second. When we do the math, we find that the area under the curve is equal to 9 meters. And that 9 meters represents the object's change in position as it was moving. These 3 points are the most important things you need to know about a velocity versus time graph. Let's quickly summarize everything we learned. Well, we learned that a velocity versus time graph has time on the x-axis and velocity on the y-axis. We also learned that if your object is moving with a constant acceleration, then your velocity versus time graph will appear linear. Then we found that the slope of a velocity versus time graph is equal to the object's acceleration. And additionally, the area under the curve is equal to the object's displacement. Now, one thing I just want to mention before we end is that you can also have velocity versus time graphs that have a horizontal line. When you see this, you know your object is moving with a constant velocity because the velocity is not changing. That means your acceleration is equal to 0. And if you were asked to find the area under the curve for this velocity versus time graph, you would need to use the area equation for a rectangle. So we know that area is equal to base times height. And that's the end of our lesson on velocity versus time graphs.